A genetically modified organism is any plant or animal that has been genetically manipulated by people in one way or another. In this presentation, I will largely define how humans genetically modify plants and why we do so. One example of how scientists genetically modify plants today is using a technique called PCR. This method of genetic engineering is used to insert a certain strand of DNA from one organism into another, thus chaining the genome of the organism permanently. This method is largely carried out through molecular methods in a lab and is generally what comes to mind to the general public when they think about genetically modified organisms. Another example of modern genetic engineering is the cloning of plants and animals. In plants, cloning is normally carried out through some form of tissue culture. This is when scientists cut off a small piece of an existing plant and place it into a cloning media that allows the plant to grow independently from the original plant. This creates a genetically identical daughter plant that is similar in every aspect of the plant that they started with. One result of such a process is the Cavendish banana. The Cavendish banana came into existence after the near extinction of the Gros Michel banana from Panama disease back in the 1960s. During this time, scientists cloned an individual Cavendish plant that was naturally resistant to the disease and spread it to banana plantations throughout the globe to replace the production of the Gros Michel. The result of this process means that almost every single banana grown throughout the world are genetic clones of one another, and that there is virtually no such thing as a non-GMO banana that you can buy at the stores. Now, genetically modifying organisms is far from a modern-day practice of farming. Since the start of cultivation, the vast majority of plants have undergone a slow genetic modification called unnatural selection. This is a process in which humans cultivate and breed whatever crops can be most of use to them, whether it be crops that better feed us, clothe us, or crops that are simply easier to grow. And similarly to how evolution leads to the survival of the fittest, this process leads to the survival of organisms that can best fulfill the needs of mankind, thus leading to the existence of most of the crops that we know and love today. One such crop that has undergone this process is the plant teosinte, as pictured on the slide. Over the span of thousands of years, mankind bred this plant to be bigger, sweeter, and more nutritious than its wild counterpart, eventually creating to what we know as corn today, a crop that has become the most cultivated and consumed crop within the United States, in addition to being a staple in the diets of billions throughout the globe. In conclusion, virtually all our foods have been genetically modified by humans through one of the various methods I've described in the slidecast, whether it be farmers back in 4000 BC breeding plants to be more edible and feed more people, or scientists of today using molecular techniques to create plants that are resistant to disease, thus allowing us to create a global food chain that is able to feed an ever-growing population with food that is easy and efficient to produce.